All right. Good morning, everybody. Okay, so we're moving on to something new today. So we're talking about generics in Java. All right, so a little bit earlier, a few weeks ago, we made a stack class, and we were storing integer values on that stack. Right, so the details of this isn't important, right? I just want to remind you that we had this stack called IntStack, or something like it. I don't remember the exact name. Right, we had an array of integer values in which we were storing the elements. Right, we had two methods, push and pop. Right, again, the actual implementation doesn't matter. What's important is that this was a stack of int values. And I guess the really important part is the only thing you can put in this stack is int values. Right, when you push an element, you can push an int. When you pop an element, you always get an int back out. All right, now stacks are pretty useful in general, and in general, you don't know. As the implementer of the stack class, you don't know what people are going to want to put on the stack. So for example, suppose you wanted a stack of strings, right? Now, before the introduction of generics into the Java language, right, one solution is you make a new class. Right? So I've already got a class that can hold ints. Now I'm going to make a second class that can hold strings. Right? So what do? Well, you go back and you look at your IntStack class, right, and you start to change stuff so that it can hold strings. Right? So here's the IntStack class, right? Details not shown, but most of the details aren't shown. Right? Now to convert this thing into a stack of strings, it turns out you just have to change a few things. Right? So first of all, you have to give it a new name, because you can't have two classes with the same name. Right? I guess you could put it in a different package. Then you change the array, right? Because now you have an array of strings instead of an array of int. Right? Now when you push an element, you push a string, right? You don't push an int anymore. And when you pop an element, you get a string back out, right? You don't get an int back out. So we've got to make some changes. If you actually go in and look at the methods, is there anything? Yes, if you actually go in and look at the methods, right? Almost nothing changes when you go and alter the methods to get to create a stack of strings. Right, so let's look at the pop method. Right, so for the pop method, what changes? Well, if the top index is -1, the stack is empty. Right, you can't pop a stack, so nothing changes there. Right, when I get an element out of the stack, right, when I go into the array and look at an element, it's a string now. Okay, so I have to change int to string. Right, now the top of the stack moves down 1. Okay, that happens in an IntStack too, and then I return the element, and that's it. Right, I just had to change these two things. Right? And the things that are changing, they're kind of unimportant. Right? All that's changing is the type of the element. Right? Nothing about the structure of the code or how the code works changes at all. Right? Everything's basically the same. So the only things that change are related to the type declarations, right? The type of the elements that are in the stack. And essentially what you're doing is you're substituting string for int in a bunch of places. Right? That's really all we're doing. Now, wouldn't that be nice if the compiler could do it for us? Right? Because then I wouldn't have to do this, and maybe the compiler can generate a bunch of classes for me. Right? So there's a language called C++ that essentially does exactly this. The language has a mechanism called templates, and when in a C++ template, the compiler goes in, makes a new class, substituting in your type for the type that's defined in the class. Right? Java generics are similar, except they don't make new classes, right? But they do let you automatically create a class like stack where you can change the type of the element in the stack. Right? Okay, now generics, turns out they were added in version 5 of the language, so they're actually a very late addition. So what did people do for the first 4 versions of the language? Right? So instead of making a stack of int or a stack of double or a stack of whatever, right, what people would do is they would make a stack of object. Right? And the reason you'd make a stack of object is because you can store any value in an object reference. Right? So, well, let's try this. Let's see what happens when we make a stack of object. Right? So this time I'm not going to use the array representation. I'm going to use the list representation of the stack, right? Just because it's easier to fit onto a slide. Right? But I can make a stack of object by changing that list so that it holds objects, right, instead of ints or strings. Right? Constructor doesn't change at all, right? Because all I do is make a new list, right? Push changes, right? So I have to push an object onto the stack. Pop pops an object from the stack, right? But otherwise, I mean, that's pretty simple to do, right? That's pretty easy to make. And I've now got a stack of objects, sorry. And you can push anything onto this stack, right? Now the problem is when you use this class, it's really inconvenient, right? It's inconvenient because you're pushing objects and, well, this is not inconvenient, this is inconvenient. When you pop something from the stack, you get back an object reference, right? So if you've got a stack of strings, when you pop that stack, you don't get back a string, you get back an object, right? If you have a stack of double, you don't get back a double value, you get back a object, right? Now you know that it might be, you know that if you're the user of the class and you know that you've only pushed doubles onto the stack, then you know you're getting back a double object, right? But as far as the compiler is concerned, you're getting back an object, right? So when you pop an element from the stack, before you use it, you have to cast it every time, right? So here's a stack of string, right? So I'll make a string stack, right? I can push the strings hello, konnichiwa, and hello onto the stack, right? That's fine, right? Because they're all strings. Now, when I want to use a string that's in the stack, I pop the stack, right? But what's the problem with that? It's an object that comes out of the stack, right? If I want to use this thing as a string, I have to cast it. So now I've got to do this cast to string, right? And then I can use the casted value as a string, right? But if I forget the cast up here, and I change that to object, down here I can't write S to uppercase, right? Because there is no to uppercase method in object, right? So this is really inconvenient. Well, it's slightly inconvenient. You have to do the cast every time. The real problem is there's no type safety in this data structure, right? Because it's a stack of object, you can put whatever you want onto that stack, right? So I can make a stack that's supposed to hold only strings, right? But there's nothing stopping you or somebody else. That's the problem when you write software in large teams, right? It's the somebody else that becomes the problem, right? There's nothing stopping them from pushing some other element onto the stack, right? So you can make a stack of strings, and then someone can come along and push a double or a date or something else onto that stack. And one of the real problems is the compiler can't help you here, right? Because you told the compiler this is a stack of object. And so as far as the compiler is concerned, you can put whatever you want on that thing, right? Because everything's substitutable for object, right? And so because the compiler can't help you, and there are really no tools that'll help you help in this problem either, right? We say that this particular implementation of stack lacks type safety, right? There's no way that you can guarantee that the stack holds any type that you want, right? So for example, I can make a stack of strings, right? I can push all my strings onto the stack, but then someone else can come along and push a 1 onto the stack. That's really weird. So now I'm pushing a primitive value onto the stack, but that works, right? Because the compiler tries to help you in this case. It says, well, 1's an int. I know how to convert an int to an object. I can convert it to an integer, right? So it auto-blocks the int, turns it into an integer object, and pushes it onto the stack for you, right? Remember, this is supposed to be a stack of strings, right? And now I've got a 1 on there. I can make another stack and push that stack onto the stack, right? I can make a date, and I can push that onto the stack, right? Now my string stack, right? It's not a string stack anymore. It's a stack of stuff, right? If someone's using this stack, whoever made this string stack variable here, if they start popping stuff off there and they think it's a string, right? So if they pop that date off, thinking it's a string, and they try to cast it to string, your program now crashes, right? Because you can't cast a date to a string. Right? Now the fact that any type of element can be pushed onto a stack, right, makes it impossible to write type-safe methods that operate on collections of objects. Right? So now it's impossible to write a method that takes in a stack and does something particular with that stack. Right? So these methods and programs that use such methods, they compile cleanly, right? So I can actually try to write a method that takes in a stack of integer and does something with those elements, right? The compiler will compile it, right? It doesn't matter how you use that stack, the compiler will compile it, right? The problem is it doesn't fail until you run the program, and that really sucks, right? You'd like to catch errors at compile time rather than catching them at runtime. Right? So you can try to write a method called sum and clear. So it's going to take in a stack. It's going to sum the elements in the stack. Right? It's supposed to take in an int stack, right? So it's supposed to take in a stack of integer values. When it's done with the stack, it's just going to pop all the elements of the stack and compute their sum. So when it's done with the stack is empty, right? Which is why it's called sum and clear. Right? It's easy to write. Right? Start out with a sum of 0. While there's elements on the stack, pop the stack. Right? Now remember, that gives you back an object, so I have to cast that. Right? So I cast the object value to an integer value. Right? And then I can add it to the sum. Right? And then when you're done, your stack is empty, and you return the sum. Right? The code is correct as it stands. Right? The sum might overflow, but other than that, the code is correct. Right? Compiles cleanly. Right? Type it into Eclipse, press the run button or the build button, and it'll compile without any issues. Right? Write some code that uses this method. Right? Your code will compile without any issues. Right? The problem is, as soon as someone passes in a stack that has a value that's not an int, this line here, right there, when you try to cast that value, now your program fails. Right? Because you can't, if the type that's on the stack cannot be cast to integer, you get a class cast exception error. Right? And the program bombs, even though the code that you've written is correct. Right? The problem is it's not correct because you can't guarantee what the type is in this stack. Okay, so in Java, in version 5 of the language, the creators of the language decided that generics would be useful. It'd be useful to be able to write a class once and be able to put any element and be able to change the type that's related to that class. Right? Furthermore, it would be very nice if it was also type safe. Right? So generics allowed us to parameterize a class or an interface or a method over types. Right? So what that means is that the type now becomes a variable. Right? So instead of creating an IntStack, a StringStack, a DateStack, et cetera, et cetera, et cetera, et cetera, right? You make a single class, right? And then the user of the class passes in a type, right? Where that type is essentially that type becomes a variable in the class itself. Right? So that's what this funny less than, greater than, something, some type in the middle notation is all about. Right? Stack integer is a stack of integers. Right? Furthermore, it can only hold integer values. Right? Stack string is a stack of strings, and it can only hold string values. Right? Stack date is a stack of date, and it can only hold date values. Right? If you try to put anything else into that stack, the compiler will stop you. Right? When something comes out of that stack, you're guaranteed it's an integer, string, or date. Right? So these classes are type safe. Okay. So how do you make a generic class? So suppose that you think, well, this is great. I want to make a generic stack, or I want to make a generic something. Right? So how do you go about doing it? Well, it turns out it's not that hard. Right? It's the same as before. You write class and then some class name. Right? And then inside the less than and greater than, you put in some variable names. Right? So these are, you can think of these as just being variables, and these are called the type parameters or the type variables. Right? So T1, T2, ... Tn. Right? So you can put as many of these in as you want. Right? You can have as many type variables as you want in your class, although most generic classes only have 1 or 2. The type parameters, there is a limitation in Java. These parameters here, they have to be non-primitive type. Right? So in other words, they can't be int or char or something like that. Right? They have to be, if you want something of int, you have to make it something of integer. Right? So you have to use the wrapper classes if you want some sort of a collection of some sort, or sorry, a generic type where the variables are primitive, where the type variables are a primitive type. Right? Okay, so when you write these type variables, the convention is to use very, very, very short names, right? So either 1 or 2 letters. is normal. Right? So by convention, the type parameters are single uppercase letters. Right? Sometimes they are single uppercase letters followed by a number. Sometimes they're a little longer. Right? But by convention, you try to stick to single uppercase letters. Use an uppercase letter because these represent types. Right? These represent non-primitive types. Right? So all of our so classes represent non-primitive types. All of our classes begin with uppercase letters. Right? So there are some common type parameter names, but there's no restriction on what you use. Right? These are just the ones that happen to be used very frequently. If you make a collection like a list or a stack, then normally the element type is called E. The type variable that you use is E, capital E. If you're making a map or some other keyed collection, right, you use K for the key. Right? If you make a collection that requires a numeric value, right, then you can use capital N. Right? If you don't care about what the type is, right, it doesn't necessarily represent an element or a key or a number, you just use T. Right? If you have more than one, you can use ST, U, V, W, X, Y, Z, something like that. Right? V is sometimes used for a value. So in a map, because a map is a mapping between a key and a value, they use the uppercase letter V for the value. Right? So let's look at a really simple example of making a generic class. Right? So one of the limitations with a Java method is that it only returns a single value. Right? It either returns nothing, so it returns void, or it returns a single value. Right? Now in Python, you have tuples, right? So you can return as many values as you like from a Python function or method. Right? In Java, you're stuck with returning one value. But there are times when you'd really like to return one or two or three or more values. Right? So for example, if you're looking for the maximum or minimum value in a list, right, then it's nice to be able to get out the minimum or maximum value. It's also nice to be able to get out the location of that value at the same time. Right? So I want to know that the maximum value in the list is 3 and it's at location 5 in the list. Right? Because maybe you want to go into the list and change that value or something. Right? So it's nice to get out 2 values in that case. Now the problem is there's no easy way to get out 2 values or return 2 values from a Java method. Right? So you can fix that though pretty easily by making a really simple generic class. Right? So you just make a generic class that represents a pair of values, right? 2 values. The class has nothing in it except for 2 fields. Right? A field for the first value and a field for the second value. It has no constructors, it has no methods. Right? In other words, it looks like that. Right? And that's it, that's your class. Right? So here's my class called pair. It has 2 generic types, T1 and T2. Right? There's nothing stopping you from making T1 and T2 be the same type. Right? So you can have a pair of integer and integer, a pair of string and string, right? Or they can be 2 different types. Right? You can have a pair of integer, comma string. Right? Your fields are public. Now this is unusual for us, right? So for every class we've made so far, you've generally been told to make the fields private. If you're designing the class for inheritance, you've been told that you can make them protected if the subclasses need them. Here, they're public, right? And they're public here because this class doesn't represent any sort of doesn't really represent any sort of abstraction, right? All it is just 2 values, right? So there's no point in trying to protect these fields from somebody using it, right? I want to return 2 values. I want someone to be able to get the first value just by writing something.first. I want someone to be able to get the second value just by writing something.second. Right? There's no class invariance or anything that needs protection. Right? Those fields don't need any sort of protecting. You're supposed to be able to use them however you want. Right? So that's it. That's your class. I don't have to do anything. Right? That's it. No methods, no constructors. Right? I don't need equals. I don't need toString. You could put them in when you wanted to, but you don't have to. Right? So how do you use it? Well, I want to find the maximum value in a list of integer. Right? And I want to return a pair now, right? So I want to return the maximum value, and I want to return the index of the maximum value in the list. Right? It's easy to write, right? You just write the max method. You just write your standard max algorithm. Right? So if the list is empty, throw an exception, because there is no maximum value in an empty list. Right? Otherwise, make a pair for the answer. Right? I'm going to store the maximum, no, I'm going to store the index of the maximum value in the first value. I'm going to store the maximum value in the second value. Right? Write your little loop. Right? So inside the loop, you just look at every element. Right? If you ever find an element that's bigger than the current max, update the current max and its index, and then return the result. Right? Now someone who gets the result just says p for the pair. Right? So p dot first, that's the index of the maximum value. P dot second is the maximum value. Right? And that solves your problem right there. The one thing that Java doesn't let you do is it doesn't let you make some sort of type where you can have an arbitrary number of these without specifying all of them yourself. Right? So in other words, there's nothing here that lets you say you want some generic type of n different elements. Right? That'd be nice if they had it, but they don't, because that would let you make an actual Python tuple if they did have that. Right? But they don't have that. So if you want to return 3 values, you have to make a separate class called triple. Right? You want to return 4 values, you have to make a separate class called something else, and so on and so on. Okay. Any questions so far? All right. So how do I turn this stack class that I've got? Right? So I have a stack of ints. We've also seen stack of string. Right? How do I convert this into a generic class? Right? So I'm going to go in and take our array-based stack and turn it into a generic array-based stack. Right? So I want to make a stack class, right? That's generic on its it's generic on its element type, right? So it can hold. I want to make a stack of any type of element, right? Or of a generic element type, right? So you put in the generic type after the class name, right? This is a collection, so we tend to use E in these sort of classes, right? Before I had a stack of int, right? Now, because I'm going to try to hold a stack of type E, right? Where E is the generic type, right? Nothing else changes here, right? I still have a default capacity. I still have a top index that's represented as an int value, right? So you go into the constructor. Now remember the constructor, our old constructor for the IntStack made a new array of int. So now I'm going to try to make a new array of generic type. Right? So all you do is substitute E for int. Right? You go and compile your code, or you look at Eclipse, and Eclipse will show you this line underlined and a big light bulb beside it. Right? If you hover over the error, you'll see this error here. Right? It'll tell you, the compiler will tell you you cannot make a generic array. Right? And you say, well, that sort of sucks because that's what I want to do. Right? I really do want to make a generic array here. Right? Because it's the element type that matters, and I'm storing the elements in this array. Right? Okay, so this is the first limitation that you run into when you try to implement a generic type, and you're using an array to hold elements. Right? So the error that you run into is that you can't make a generic array in Java. The language doesn't let you. Right? I'll explain why in a moment. So to fix the problem, you can make, there's two approaches. One way to fix the problem is to make an array of object, right? Which kind of looks like this stack of object that we had from before, but you'll see in a moment that it's not exactly the same thing. Right? So I can make an array of object because you can store any reference type you want in an object variable, right? Which means I can store any reference type that I want in an array of object. Right? Now, when I write pop, right? So when I write the pop method, I still want to return the generic type. Right? I still want to return type E, so I can cast whatever value I get out of the array to type E. Right? Okay, so I'm going to change that E to big O object. Right? In the constructor, right? Now I can make a class, an array of type big O object. Right? Now, why am I making this array of type big O object? Or sorry, why? Yeah. So why do I have to do this? Why doesn't Java let me make a generic array? So arrays in Java are said to be covariant. Right? So what that means is, if you make an array of object, right, and you make an array of any other reference type, right? Whatever that thing is there, that's a subclass of the array of object. Right? So an array of string is considered by the language to be a subclass of an array of object. Right? If you had a what would be a good example? If I have an array of counter, right? Then I can have an array of a stopping counter, right? And that would be a subtype of the array of counter. Right? So that's a little bit strange that the language does it this way. So for example, does that compile? Right? So if I make an array of big O object, can I store an array of integer in that field? Right? Well, you go back here and you say, well, that's substitutable for that. So that's definitely substitutable for that. Right? So the answer is yes, right? That actually works. Now, does that compile? So this is a little strange, right? So objects 0, or obj s0, right? That's the first element of the array, right? Am I allowed to store a string in that array element, right? Or does the compiler let me store that string in the array element, right? So what does the compiler do? It says, well, what's the declared type of objs? Well, it's object, right? It's an array of objects, so yeah, I can store that in the array of object, right? So unfortunately, this compiles in Java, right? And without any warning, it does compile, right? Even though your actual array is an array of integer, right? So that turns out, yes, it compiles. Does it run? The answer is no. So it fails at compile time, right? Why does it fail at compile time? Because you try to take this string, and then at runtime, it tries to put it into this array of integer, right? And that doesn't work because a string is not an integer, right? So this one fails at runtime, right? Now, generics in Java are not covariant. Okay? So generic classes, not covariant. They are invariant, which means their types, the generic type actually matters in this case. Right? So if I try to make a list of object, right, and I have a list of string, yes, they're both lists, but they're not related in any other way. So they're not related by inheritance. Right? So in other words, I can't take a list of string and store and substitute that for a list of substitute that for a list of into a list of object. Right? So yes, string is a subclass of object, right? But a list of string is not a subclass of a list of object. Right? So does that compile? The answer is no. Right? Array list is substitutable for list, right? But array list of integer is not substitutable for a list of object. Right? So when you try to do this, that type doesn't matter. Right? So that type does matter, right? So you cannot, in terms of substitutability, right? This type now matters. Right? For arrays, it doesn't matter until runtime, right? This error is caught at compile time. Okay. The methods push and pop, right? So what do you have to change to the class to implement push and pop? It turns out you change almost nothing, right? So push, you now change the parameter from int to e, right? When you resize the array, right, you have to remember that your array is now an array of big O object, right? But that's it. Nothing else changes, right? So your array type changed, your parameter up here changed, the parameter type changes, everything else stays the same, right? So there's no changes, very few changes here. Right? Now, for the push method, right, the push method always takes in a type E, right? So it always takes in the generic type that the user of the class has specified, right? So they make a stack of integer, right? Then in the push method, that becomes big I integer, right? So when you store that element into this array of object, right, you know that for sure you're always storing an element whose type is big I integer, right? So the elements that you're putting into the array, they always have the correct type, right, for whatever type of stack that the user is creating, right? So you know for sure that that array always holds elements of the same type, right? Which is nice, right? Because if you just make that big O object, then you have no idea what type of elements are in the array. Okay? So at compile time, right, the compiler can check, is every element that you're putting into this array the correct type, right? Now what about pop? So again, pop doesn't really change, right? So when you pop, you return an element of type E, right? Before, this stack would be of type int, right? But I need to return an element of type E, right? That thing there is actually an array of object, so I cast the element that comes out to the generic type, right? And I store it in a variable called element, right? At the bottom, I return element. Otherwise, nothing changes. Right? The cast is needed here because that array is an array of object, right? It's not an array of E, it's an array of object, right? That cast always succeeds, right? Because the only way I can put stuff onto the stack is via push, right? And push always stores elements of type E in the array, right? So I can be guaranteed that this cast always succeeds, right? I never have to worry if there are strings on my stack of integer. Okay? So that cast always succeeds, and it always returns the right element type. And that's it, you're done. Your generic stack class is finished, right? Which actually wasn't very hard to do at all, right? I just want to check if okay, so now we've got a generic stack class, right? But we also had an interface, right? So before we had an interface of, I think we did string, but it doesn't matter. We had an interface of something, right? Some stack of something, right? I think it was a stack of string, right? So now I want to convert that interface to be a generic interface as well, right? So now I want to be able to make a stack of some element type, right? And this turns out to be really easy to do if you have an existing interface already, right? We had a stack of string, now I want to make it a stack of E. So all you do is you add the generic type variable after the interface name and change string to the generic variable name, right? So there's our original interface, right? And you have the source code for all of this, right? It's in that package up there. So this was our interface for strings, right? So when you push an element, it's always a string. When you pop an element, it's always a string, right? To turn this into a generic interface, that's all you do, right? So now it becomes a stack of some generic element type, right? When you push an element of type E, and when you pop an element, you get an element of type E, and that's it, right? So you now have a generic stack interface, and you've got a generic stack class, right? So now you can go off and make a stack of big I integer, and it'll always hold integer values, right? And it can only hold integer values. It can't hold anything else, right? You try to put anything else, any other type onto that stack, the compiler will complain, right? So you now have a type-safe generic class and a type-safe generic interface, right? Finally, the last thing to do, right? So what did we have back here? So way back, right? We called our class, we can change the declaration, right? So we made a generic class called ArrayStack, right? But that ArrayStack class actually implements a generic interface. So if we wanted to, and you probably do want to in this case, right? You can now go back to your stack class and say that it implements our generic stack interface, right? But that's easy to do too, right? You just write implements stack and then the generic type, right? So ArrayStack of E implements a stack of E, right? And now you've completed the generification of both the interface and the implementation, right? So it turns out it's actually very easy to do, right? The syntax is a little wonky, but it's actually pretty easy to do, right? The syntax is funny because the addition of generics came late to the language, right? It came in version 5 of the language, right? So they had to come up with a different syntax to indicate the generic type, and this is the one they hit on. Now I should go back and explain what's going on with this array here, right? So why does Java not let you make an array of E, right, of generic type? And so the reason is related to this slide here, right? So Java doesn't let you make an array of generic type because at runtime, the rule in Java is at runtime, the virtual machine must be able to determine what type the array holds. Right? So in other words, the declared type of OBJS is big O object, right? So it's declared as an array of object, but its actual type is an array of integer. Okay, so at runtime, the virtual machine knows that OBJS is actually an array of big I integer. Right? So when you do something like this, when you try to put a string into an array of integer, that's why at runtime it fails. Right? Because the virtual machine knows that this really is an array of integer, and you can't put a string, you can't substitute string for integer. Right? So that's the rule. Right? So the rule is at runtime, you must be able, or the virtual machine must be able to determine the element type of an array. Right? The way that generics are implemented, right? So when you say list of blah, right? Or list of E or stack of E, I guess, but let's go to the stack. Where's my interface? Here, right? So when I say stack of E, right? What actually happens is, right, underneath the hood, what actually happens is you end up with a stack of big O object, right? So that's actually what happens, at least in this implementation, right? So the array that's holding everything is actually a stack of big O object, right? So what happens is everything is actually being cast, or everything is being stored as object references inside the stack, right? Or any generic type, right? So if you have a list of blah, inside that list class somewhere, there's a something of big O object, right? So in other words, everything is actually a something of big O object when you write a generic class, right? What actually happens is the compiler checks. So the compiler is able to check any use of the generic variable name, right? So in push, right, when you try to push something onto the stack, the compiler can check if that E, right, if the element type that you're pushing is the same as the element type up here. Right? Similarly, when you pop an element, right, the compiler can check if the value that you're popping, right, is always convertible to type E. Right? So the compiler can do everything for you. So it can check if all the types are correct. Right? But what happens at runtime is this generic type disappears. Right? So if you make a stack of integer at runtime, the virtual machine has no idea what it's a stack of. It just knows it's a stack. Right? As far as it's concerned, it's a stack of big O object. Right? So at runtime, you don't know what the generic type is. Right? That's how Java generics were implemented. Right? So the implement was called type erasure. Right? So the generic type information is lost at runtime. But that's why you can't have an array. That's why you can't have an array of type E. Right? Because the type information is lost at runtime, you can't know what the element type is in an array, right? But the rule in Java is that you must be able to determine, the virtual machine must be able to determine what the element type is of an array, right? So that's why you cannot make an array of type E, right? Because of the generics are implemented using erasure, right? So the runtime type of the generic type is lost. So the rule of thumb is you kind of want to avoid using arrays if you can when you're implementing generics, right? If you are using them, then you have to do what I showed you here, right? You're storing and casting, right? So I'm storing everything in an array of object, and when I need the element, you're casting it back out. Right? Alrighty, I think that's everything. Yeah, that's it for today. I think in the next class, we'll continue. So we're going to do some more generic stuff. So we're going to convert the node-based stack to a generic class, but that turns out it's very easy as well. And then we're going to look at some other generic collections as in the next couple of weeks. All right. So that's it for today. See you on Monday.